Good evening, everyone, and welcome to AstroNights Live, presented by the Krista McAuliffe Center for Integrated Science Learning at Framingham State University. Once again, we have a fascinating presentation planned for you, and we're very excited you chose to spend a little of your time with us tonight. My name is Mary McDonald. I am the manager of the Framingham State University Planetarium, and I am usually your guide for AstroNights. But tonight, I am once again turning over the duty to one of my colleagues, John Sheff. John is a lifelong amateur astronomer and space buff. As a NASA Solar System ambassador, John has a particular passion for planetary exploration. He loves to share views of the sky through the observatory telescopes he operates during public nights at the Harvard-Smithsonian Center for Astrophysics in Cambridge. John regularly teaches a popular astronomy course at the Cambridge Center for Adult Education. And since 2019, John has been a part of the education team at the McAuliffe Center, where he has led a variety of educational programs, both in person and online. Tonight's presentation will be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating in Zoom can post questions via the Q&A window. You may want to hold your questions until the end because your question just might get answered during the presentation itself. If you're joining us via YouTube Live, unfortunately Q&A is not available, so just sit back and enjoy. Whether you are joining us live on Zoom or on YouTube, we recommend taking a moment to locate the full screen mode in that app for the best AstroNights Live viewing experience. Any websites or resources mentioned during our program are available on our website, so don't worry about rushing to write anything down. Just relax and enjoy the program. The links will be waiting for you there whenever you're ready. You will be invited to complete an online survey at the close of the program, and we hope that you will take a moment to share your thoughts with us. Your feedback helps us in planning future AstroNights Live events. And now I would like to officially introduce our presenter, John Sheff. John, the sky is yours.
Thank you, Mary. I'm going to start sharing my screen so we can all see the same thing. Hopefully you can all see our sunset scene. And I am going to stop my own video. So greetings, fellow astronomers, and welcome to AstroNights. The stars, aside from daily and annual motions, don't appear to change very much on the scale of a human lifetime. But in fact, they're born, live, and die on timescales far vaster than we can experience. We can't follow along with a star as it goes through all of its life phases, but what we can do is look at some stars that are in different stages of their lives. But let's start with what our local neighborhood looks like now. This is the view we would get at about 8:30 tonight, a few minutes after sunset. You may notice that there's a bright star in the horizon near the middle of the image. It's actually not a star at all, but the planet Venus. Venus is the brightest point of light in the sky, but I'm sure you've spotted another solar system object as well. The moon is now a waxing crescent, about 6 days old. It's a beautiful sight in the evening, as I'm sure you've noticed, or you will notice in the next few days when it's supposed to be nice and clear. And as I'm sure you've noticed, we have very short nights at this time of year. So sunset is about as late as it can get. In fact, the summer solstice is in just 4 days on Sunday. So to get a view of the fainter objects in our sky, we're going to advance the time to 10 p.m. We've also changed the direction we're looking to south. we can still see the moon visible in the upper right. We can also see a bright bluish star to the lower left of the moon. That's Spica. Spica is a bluish star. The colors of stars are subtle and not that easy to see with our eyes, but scientists analyzing their light can tell a great deal about the star's nature. Spica is the brightest star in the constellation Virgo. Though we can't see it with our eyes, Spica is actually a double star. Each is a type of star we call a blue giant, and for a good reason. This is an artist's conception of what Spica might look like close up. The larger of the pair is about 10 times more massive than our sun, and 7 times the sun's diameter. The star's blue colors indicate that they're young, hot stars. It may seem strange, but big stars like Spica don't last very long. Even though they have lots of fuel, they use it up very quickly. Very small stars, on the other hand, with little fuel to begin with, can last for much longer periods of time. Spica is estimated to be about 12.5 million years old and may only have another few million years of life left. An average-sized star like our sun can last for billions of years. It's almost 5 billion years old, and it has enough fuel to last for about another 5 billion years. In the first step of a star's life, a star is formed from the collapse of a huge cloud of gas, mostly hydrogen and dust. The new star's energy comes from this process that converts hydrogen into helium. Most stars that form are typically very small and dim, so dim that we can't even see any of them with our naked eye. Our sun is an average star, and we can see a few others like that without a telescope. But most of the brightest stars we see in the sky are bigger than the sun. How did they live their lives? To see a star much more advanced in age than the sun, or Spica for that matter, let's look at the constellation Scorpius. We're still looking south, and we can see Scorpius rising over the horizon. You may notice the bright red star in the Scorpion's heart. That star is called Antares. Antares is a type of star called the red supergiant. This is an artist's conception. Antares is at least 12 times the mass of the sun and over 680 times its width. In fact, if you replace the sun in our solar system with Antares, its surface would extend to between the orbits of Mars and Jupiter. In spite of the huge amount of nuclear fuel it has available, it may be no more than 15 million years old and may have less than 10,000 years left ahead of it. What happens after that? Sometime soon, maybe tomorrow, maybe in a few thousand years, Antares will run out of fuel and explode. This will produce what we call a supernova. There are many recorded instances of supernovae in the past. Some have appeared as bright as the full moon and been visible in broad daylight. Most such supernova remnants fade below naked eye visibility after a few weeks or months. We can look at the place where these supernovae were observed to see what remains. We can see the debris from one such supernova in the constellation Cygnus the Swan. Let's turn east to take a look at that. Cygnus the Swan is just rising. Within the constellation is a well-known supernova remnant, the Veil Nebula. The Veil Nebula is the remains of a supernova that exploded about 10 or 20,000 years ago. We can't see the nebula with the naked eye, but a telescope reveals the remains of the explosion. Some of this material blown off will be used in the formation of new generations of stars. After the supernova explosion, all that remains of the exploding star is a dense core, which may be a neutron star with several times the mass of our sun, compressed into a size no bigger than the size of a city. Or it might even result in a black hole. In fact, there is a black hole, the first one ever confirmed, not far from the Veil Nebula in our sky. It's called Cygnus X1. Of course, a black hole, by definition, is invisible because no light can escape from it. However, as this artist's conception shows, swirling gas that the black hole pulls off a companion star heats up to enormous temperatures as it spirals into the black hole. This gas emits lots of X-rays. However, our atmosphere absorbs those, so Cygnus X1 was not discovered until rockets could send detectors above Earth's atmosphere. Well, we've come back to our familiar surroundings just after our own long-lived star has set. And with that, we wish you a good evening, and we will be opening this up to the Q&A portion of our presentation. Okay, if anybody has any questions. Oh, I see a question from Mary. Was the sun a different color when it was born? As far as I know, it was not. It's always been roughly the same color. But the sun was it was cooler and smaller. In fact, there was a problem called the dim young sun problem, which accounts for why Earth doesn't actually, why Earth wasn't cold in the beginning. So we're trying to figure that out, why the Earth's temperature was normal and could support life even when the sun was smaller and dimmer. I have a question from Haifa. What's the difference between a supernova and a nebula? Okay, so a supernova explosion itself is basically a small point of light that gets very bright, and it does leave a nebula behind, a supernova remnant. But there are other types of nebulas besides supernova remnants. For instance, nebulas like open star clusters, like the Pleiades star cluster, the Seven Sisters. That's a nebula that represents stars that are being formed as opposed to stars that are dying. And there are different types of nebula also, like planetary nebula. Our sun does not have enough mass to become a supernova. It will never explode as a supernova, but eventually when it runs out of fuel, it will cast off its outer shell and create what's called the planetary nebula. And we see some of these in our sky, and they're very beautiful. I have a question from Virginia. Please explain again how a supernova turns into a black hole. Okay, that's a really good question, and a lot of research has been done on this. Basically, when a supernova explodes, part of the energy of the explosion goes outward to cast off those outer layers of the star. But a lot of the explosive energy goes inward to make the core of the star actually collapse. It's pushed and compressed into a tiny area. Depending on the mass of the core, it can become a neutron star. And that's probably what happens most of the time. But if the core remains very, very massive, it gets compressed even beyond the compression that results in a neutron star, and then there's nothing that can prevent the star from collapsing even further. It's so large and so dense that its own gravity pulls it into a black hole because it's so dense. I hope that helps a little bit with that answer. Question from Mary. What was that big blue mass next to the Cygnus X1 black hole? That's a great question. And that was actually its companion star. The black hole was actually pulling material off of its companion, that big blue star. And the material was swirling down into the black hole and giving off X-rays and other sorts of energy, which enables us to detect the black hole. Okay, let's see. I'm looking for other questions in the Q&A. That question made me wonder. Halfa says, that question made me wonder, can black holes die? Yes, they can, but it takes a really long time, many times longer than the current age of the universe. So black holes, initially people thought black holes could only get bigger as they swallow more and more mass. They can't get smaller. But Stephen Hawking, the astrophysicist, proved that actually black holes can decay over very long periods of time. They can give off very dim radiation, and they actually have a temperature. And when they start giving off this radiation, they get smaller, slowly at first, but eventually they get smaller and smaller and give off more and more energy, and the process accelerates till the black hole evaporates. And that results in a explosion, not as powerful an explosion as a supernova, but it's something that would be noticeable if a black hole dies. The trouble is, probably no black hole has died yet in a universe because not enough time has passed for that to happen. But eventually, trillions of years from now, black holes will evaporate and disappear. A question from Shepley. How does a star get its energy during its lifetime? So remember that diagram where I showed the particles shooting around. So a star winds up composed mostly of hydrogen. And when hydrogen particles fuse together in the intense gravity and heat in the core of a star, they fuse together into helium, which is the next heavier element after hydrogen. But a little bit of energy is left over from that. It just doesn't result in a helium atom. It results in helium atom plus a lot of energy. And this reaction is going on trillions and trillions of times a second during each star's lifetime. And that's mainly what the energy source of a normal star is. When it gets close to being a supernova, that helium gets burned into even heavier elements. But normally it just it's hydrogen being converted into helium. That's the status of our sun right now. A question from Sharon. You mentioned blue stars burn up their fuel faster, but why is Antares a red star so short-lived? Good question. And we think that Antares at one point used to be a blue star, actually. And as it evolved, when a blue star burns up its fuel, it eventually turns into a red giant star. And so a red giant star will also have a very limited lifetime. When we talk about the lifetime of a blue star, yes, they burn their fuel faster, but eventually when they burn enough of their fuel, they'll turn into a red star, and that red star will have a short lifetime. Question from Anna. Would a black hole ever be able to go around Earth? If one was close and happened to be near us here in the galaxy? Well, it's possible, but black holes that exist today are very massive, and we would know if a black hole was approaching. And the other thing is that to remember is black holes are not like cosmic vacuum cleaners. They don't suck things in. If a black hole passed close to our sun, for instance, or even our Earth, but didn't hit it, it would just harmlessly pass by. It wouldn't actually it wouldn't actually suck the Earth into the black hole. The gravity of a black hole is not any stronger than the gravity of the core of the sun that collapsed to form the black hole is. So the black hole would probably be, certainly it might cause changes in the orbits of the planets as if it went through the solar system, but it would not cause any damage to Earth or other planets unless it was a direct hit. So I hope that answers your question, Anna. Let's see. Another question from Anna. Do black holes move? And if so, do they have orbits? Well, yes, basically everything in a universe moves. In a black hole, for instance, in that diagram I showed with the companion star that the black hole was sucking mass from, that those two are a double star system. So the black hole and the biggest star revolve around each other. They have a common center of gravity, so they do orbit sort of around a common center of gravity that's somewhere between them. And black holes can move. Some of them have actually been known to be moving quickly through the galaxy. They've probably been ejected by supernova explosions of their companion stars. But yes, they do move, but the galaxy we live in is very, very large. So chances are that of them colliding with any other star are very, very remote because the stars are spaced so far apart. Question from Stephanie. Can anything suck up a black hole? The only thing that I can think of that would suck up a black hole is a bigger black hole. And that, in fact, we've seen that happen. Lately, we've been able to detect gravitational waves. And gravitational waves let us see things that other forms of observation don't. And one of the things we've seen is black holes that are orbiting each other, for instance, sometimes actually collide and merge. And they give off an enormous amount of energy, particularly in the form of gravitational waves. And now we can detect those and we can tell the size of the two black holes that collided. A black hole could also collide with a neutron star and suck up the neutron star. But generally, the only thing that can suck up a black hole is another black hole. Okay, let's see. Do we have any other questions? Okay. So far, we don't. It looks like. Oh, question from Hylfa. When will the next AstroNights live event be? Actually, that's a good question, and maybe Mary can answer that. Let's see.
Oh, hi, Thea. Thanks for the question. AstroNights Live are held monthly at the moment. So the next AstroNights Live is going to be on the third Wednesday of the month, which will be July 21st. For a while, we were holding them on the third Friday of the month. Now we're doing the third Wednesday. And I just want to put in the chat that you can always find information about AstroNights at our website, which didn't come out in link form. Let me try this a little bit differently to get a link to you all. It's cncenter.org/AstroNights. There you go. That should be clickable. And you can find all of our upcoming events as well as other useful resources.
Okay, so it's about 8 o'clock. So I think unless anyone else has other questions, I think it might be time to wind it up.
Yeah, I think so too. I just did see one question in the chat or questions that I wanted to address, which was how do I get notified of the upcoming events? And I would say that the best way to do that is to join our mailing list. So, oh no, that's not a very good link to share. Just a moment, everyone. Yeah, so joining our mailing list is the best way to get information about our upcoming events. And I'm going to put a link in the chat that will allow you to join our mailing list. But I just want to not overwhelm you with there we go. Okay, so I just put that in the chat. It is the link to join our constant contact mailing list.
I see a question from Virginia. Is your observatory open to the public now? We don't have an observatory, but we have a planetarium. So and Mary's the director, so maybe she can give us an answer on that.
I'm the manager of the planetarium. So not quite director. Yeah, so the planetarium at Framingham State University will be open in the fall. We are going to be having some limited opening over the summer, some public events, late summer, so not anytime soon, late summer. It's not 100% confirmed yet, but I would again say that if you are not already on our mailing list, you should get on the mailing list, because that will be the best way to get notified of exactly when that's going to happen. I just wanted to check to see if perhaps the question was actually referring to the public observatory at the Harvard-Smithsonian Center for Astrophysics, where you volunteered at one point. I don't know if you know anything about that.
That is actually closed right now, but it should be open in the fall. I know for a fact they're planning 2 events in the fall, 2 public events, and if the weather's good, I'll be up there and other people will be up there operating a telescope. But they haven't announced the exact dates for that yet, so stay tuned for that. Any book recommendations for 9-year-olds interested in this type of stuff? I would say the best bet is, well, we have some references on our website regarding this material, but also I would just Google it and Google something like Lives of Stars or stellar evolution, and you'll get a whole list of links, and particularly, you could go to Amazon and Google that, Lives of Stars or stellar evolution, and I'm sure you'll get a whole range of book listings on the topic, and you can pick one that is appropriate to your age group. Okay, with that, oh, you're welcome, everybody. Thank you for coming. I think Mary's typing an answer also about the book recommendations. You're welcome, Virginia. Thank you for joining us today. Oh, question from Stephanie. Have you ever seen a black hole eat another black hole? Well, yes and no. It depends on, I guess, on what you mean by see. We've observed 2 black holes merging, yes, on several occasions, and they generate a lot of what we call gravitational waves, disturbances in space-time. And they're very small disturbances, but we have instruments now that are sensitive enough to pick up those signals and even tell us the size of the black holes that before they merge and the size after they merge. So we're starting to see more and more of that as time goes on. Okay, and I think we do need to wind up, right, Mary? So let's just thank everybody, and I hope everybody goes out tonight and enjoys seeing Venus and the moon, and maybe later on after dark, some of the constellations we talked about. Okay, well, we hope to see you next time, and thank you all very much for coming, and your questions are really appreciated.